Before you begin a volumes calculation task, it's important to decide which volumes method suits your situation. In Microsurvey CAD, you have three methods to choose from. You have volume by entity, you have surface volume, and you have area volume. I'll go through some examples where you'd want to use each method. What we're looking at here is an example of a classical stockpile situation where we have a red 3D polyline that defines the bottom of a stockpile, and it's also going to be used to represent the ground before the stockpile was added. And then we've got a series of shots across the top of the stockpile, and that's going to represent the finished stockpile. The surface volume method is ideal for this type of classical stockpile or a tailings pond, or also if you've used one of the design functions in Microsurvey CAD and created a design surface from an existing ground surface. What you're going to do is use the polyline to create a bottom surface, and if we turn this upside down you'll see that that's represented by the red, and you're going to use both the polyline and all of the surveyed points to create a top surface, and you can see that represented in blue. Now let's switch drawings and look at a different situation. So here's a situation where the client wants a volume calculation by comparing field work from one day and then field work on another day. And so what we've got here is a closed polyline that represents the building area, and I'll turn on some extra layers here so that you can see where field work was done on the first day before some earthwork took place, and later on the field crew came back and did some more field work and measured the ground after some earthwork took place. And so we're going to be able to use the points from those two surveys to represent a before and an after surface. Now, the 2D polyline is important because we're going to use it to restrict the area in which the volume is calculated. And the reason we need to do that is because when I take a look at the tin that's derived from the fieldwork, what we'll find is, if I compare these 2 days, you'll find that the surface generation algorithms sometimes create extra triangles that are beyond where we've done our field work. And you'll find that with both the surfaces. And if you were to use those extra triangles, so here's another example here, if they were to be included in your volume results, they would be inaccurate because they're not backed up by field work. I'm going to switch drawings one more time, and I'll show you the entity volume method. So entity volume is uncommon, but sometimes it's useful for unusual situations. What this will allow you to do is explode a tin that you may have created from your own fieldwork, or it may have been mailed to you from another CAD program that also generates tins, and it'll give you a volume result down to the zero elevation. And there's a related function in utilities called surface area, and it will give you essentially a slope area, which in this case is useful for calculating how much asphalt is required for this little road area. So watch the following volume movies to get into the details of how each of these volume methods is applied.